Hello everyone, welcome back to another Sunday video. Today I'll be talking about Solidity data types, especially data types that would be useful for on-chain analysts. So I think in general, you can think of data types as in two buckets. There is the static data type and then there's the dynamic data type. I've got some notes here, but I think it's better if we jump straight to an example to show you what I mean. So right here I have a swap transaction. This is a swap on Uniswap v3 and this is a swap on Uniswap v4. And all the data types are in green. So you've got address, you've got int 256, uint, and then even for v4 there is bytes 32. So what is static? Static data type is when there isn't this symbol. I don't know, brackets. There isn't a bracket in the data type itself, right? Look at this. int24 has no bracket, right? Address has no brackets. And so because they have no brackets, you can think of it as they are static, which also means there is only just one, right? Let's contrast this with this transaction over here, where you see there is an address and then there is a bracket and then 2, right? So this means there are two addresses essentially. So the fee recipients variable is an array, and it's an array of 2 addresses, right? So that's how so that's the 2 categories, right? So static and dynamic. And based on whether it's static or dynamic, there are different rules, or specifically just a dynamic, there are a few rules you need to apply to extract dynamic data types. But I think, yeah, so those are the 2 categories, and these are the common ones you see, right? So earlier I showed that we can see uint 256, but uint can also be a dynamic uint, right? Like something like this, right? Uint 256 and then brackets, and then 256 here just means how big of the value it can store, right? So 256 is the max. Yeah, and something I forgot to mention is all of EVM data is stored in hexadecimal format, right? So a bunch of alphabets, a bunch of numbers, right? And so because of that, every time you extract all this information, you would need to either convert them to integer, or if it's a string, convert them to string. If it's an address, you can use it as it is. So those will depend on the data type itself. Okay, let's first start. uint 256. So uint means unsigned integer, and unsigned just means there is no negative, which means it is always positive. Right? You see this mostly in Uniswap v2, where all of the amounts are in positive values. And then signed integers, or just int, like this, right? int 256 means it can be positive or negative. You would see this in Uniswap v3 and 4. So example would be just right here, right? Amount 0 is a negative number, and you would see this reflected in the data type here in the event logs as well, right? So int 256, this should tell you this is a signed integer, and you would apply the S to C, so you call it, right? So something like live query.utils.udf hex to int. Oops. This is how you convert hex to int, but because there is a to handle signed integers or like negative numbers, you would add a S2C here, right? Signed to complements. And let's say your column is called data, so it's something like this, right? So this tells it to convert from hex to int, but also convert the negative numbers correctly. And we also see sometimes where timestamp is used. So someone would convert a timestamp to Unix form, which means a bunch of integers, and convert them into hexadecimal format. So I have an example, I think here. So you see how it says load maturity date, and then it's a bunch of numbers, right? And based on the variable name, you would think it is a timestamp, but there's no way to store timestamp on EVM. So people usually store it in Unix form, and you would convert this something like Unix to timestamp website, like this. Oops, and then you convert. You can see it's a readable timestamp format. So this number converts to this number. And how you know it's timestamp? There is no formal way of knowing. It's just really just based on the variable name and the context you're in, right? So in this case, this is an NFT loan, and so that's why there's a sort of like a timestamp element to it. Yeah. Okay. Next one is address. Address is pretty unique to I guess blockchain data, where in EVM it is the what do you call it? It is the length is 20 bytes, and 20 bytes means 40 characters long, right? Because 1 byte can be represented by 2 characters, so 1 byte you need times 2 to get the length of the characters. So if you count this address over here, it will be 40 characters long, and then you plus the 0x, which will add up to 42 characters long. But usually it is stored in like so. So you take the last 40 characters long and cut that out, usually with substring or with the write function, and that is your address. You add a 0x in front, and that's your address. Now, why is there a bunch of zeros on the left of the address? Well, it's because in EVM data, it is all aligned to 32 bytes. And again, 32 bytes means 64 characters long because you times 2. And so this length, if you count, is 64 characters long. But because the address only fills 40 characters, that's why it is left padded with a bunch of zeros. Now, address is left padded, but other things like string and bytes, those are right padded, which means they start from the left. And let's say, we'll go into detail in a bit, but right, I'm gonna scroll in a bit. Let's say your bytes is, let's just say it fills only this part here. The rest of this will be padded to 0. Right, and address on the other hand uses a space, and whatever amount of space that is not used, they add zeros to the left of it. So that's how addresses work. I think, yeah, right. I think addresses are quite straightforward. And then Boolean. Boolean is another type. Let's see if I have an example here. I'm not sure if I do. Boolean. Okay, I don't think I do, but basically Boolean is 1 is yes, or 1 is true, 0 is false. And how, because again, this is all represented by hexadecimal format, so it will be a bunch of zeros. Right, imagine this is a Boolean type. Oops, it will be a bunch of zeros, and then right at the end is either 0 or 1. And so based on that, again, convert that from hex to int, and you get either 0 or 1. 1 will be true, and then 0 will be false. Next is, the last common data type is bytes 32. or it can be 16 or 18, right? Or bytes 1. Again, this just means how much it can store, and bytes 32 means it takes up the whole length of this thing over here, right? It takes up the whole 32 bytes length. Now, I get a lot of questions asking like, how can I decode bytes 32? The simple answer is you don't, because bytes 32 is usually you apply a kcat 256 hash function on it, and the result is a bytes 32. So there is nothing you would decode. It is just, you can use it as is, right? I think I have an example here with Uniswap v4. Let's see. Yeah, there you go. So bytes 32, you can see here, is ID. In this case, is the pool ID. And yeah, this is the ID, right? You can use this field or variable as is. Because it is bytes, there's nothing for you to decode. You don't have to convert it to a string, no conversion to integer, right? You just use it as it is. I think that's it. I think that's it for static data types. So I think very common. Maybe I'll do an example just to show you. So let's take this Uniswap v4 as an example. So select from. Now, reminder again, these are all in the easy decoder event logs table, so you can just pull the data out very easily. But if you want to dabble in raw data, this is what it looks like. So the fact event logs table, right? My contract address is this, and then let's add a timestamp filter. Let's say 15, and then I need my topic 0, of course. Topic 0 for swap is this. Okay, and then I just want the data portion, which is this. Topic 1, let's see, does it use topic 1? Yeah, topic 1 and topic 2. Oops, I needed that a little bit. Okay. Okay, I already have a transaction hash. Okay. So I'm just running a query to look at any random 10 transactions from the event logs table, looking at the Uniswap v4 contract with this topic, which means it's a swap event. And I want to show you how to sort of extract the necessary information. So first up, we have topic ID 1, which is the bytes 32 ID. So because again it's bytes 32, nothing to be done there, you would just use topic as it is, right? Is it? Yeah, 5999. I mean, this is not the right transaction hash. Let's go to the right hash. Yeah, it's either this or this. I think it's this because it's D269. D269. So you will use topic 1 as it is, right? Maybe I'll just even do like remove the first two, call this as ID, which is the pool ID, by the way. And then the next one is address, and address is 40 characters. So you can either do something like write and then 40, but I usually do substring 27 as sender. Don't forget to concatenate. Yeah. Now why 27? Because in topic there is an extra 0x, so I need to add 2. And then if I don't add, if it's not in topic, if it's in data instead, this will be 25 because I start on the 25th character, which means I disregard 24 characters of the full length of 64, which would mean I'm taking the last 40, right? So this is a long-winded way of saying I'm just taking the last 40 characters and then slap a 0x in front. There you go, right? So this looks nice. Okay, what's next? Next is no more index topic. So we jump straight into data, the data column. And this is an integer, a signed integer. So which means we need to apply the unsigned integer, the signed integer function, which should be the, it's over here. So I'm just going to copy that. And this will be part 0. Call this as amount 0. And the rest is just unsigned integer. You can just use the hex to int conversion regularly. And there you go. So amount 0, you have positive numbers and you have negative numbers as well. So that's how you convert address, bytes 32, and also for signed and unsigned integers. Okay, so I'm going to leave a note here. So address, signed, unsigned, bytes 32. Okay, the next category, or the second category of data types are what we call the dynamic data types. And why dynamic is because they do not have a fixed length of variables. The variable itself does not have a fixed length, right? So contrast this, right, address to recipients with something like this: uint 256 and then open bracket, close bracket, which means this amounts variable can have any number really of uint 256. So it can be 5, it can be 10 in another transaction, it can be 1 in this transaction, right? It is a variable, and that's why it is a dynamic data type, as compared to this where the number of elements in this array is fixed. That's why this is a static data type. Okay, so bytes and strings follow a certain rule. So the rule is this for bytes and string. First rule is there's an offset. And what offset it means is it just tells us where does this bytes and string start, or where can we look for this bytes and string, right? So where can we start looking? Now, why is there an offset? Because bytes and string are dynamic, right? They can be more than 64 characters long, right? And so because they are dynamic, you need some sort of way to know how long it would, where you would start, where it starts, and then like how long it would, how long is that thing actually is, right? So that's why there's an offset. Whenever there's a dynamic data type, there's always an offset. And then for bytes and string, once you figure out the offset, you would go to the offset, and the first thing that you will see is the length. So length of bytes or string in number of bytes. So let's say the length of bytes, the line that you're looking at is 32. Okay, it says 32 after converted from hex to int. Now 32 here is the number of bytes. It's actually not the length of the bytes, so you need to times 2. So 32 times 2 is 64, which would mean the next line, the next time you look, immediately after this indication of length, the next 64 characters long is the actual byte, or is the actual string. Okay. And then followed by actual string or byte. Now, one quick note here: why is this bytes different from bytes 32? Well, bytes 32, having the number there fixes its length, and it fixes the length to say like I'm only going to occupy 32 bytes essentially, whereas bytes just by itself is dynamic and it is not limited to just 32 bytes. It can be way more than that, and that's why it's different, right? So these two, even though they are named the same, they are very different, and how you would sort of extract them are very different as well. So bytes 32, actual string bytes. I have an example. I believe it's this. Let's see. Yeah, let's take this for example, right? So what transaction is this? Okay. Me 17. Okay, so I'm gonna copy this, and then I'm gonna modify it and do transaction hash is this, and this is May 17. So May 17 address is this, and then topic is this, and then I can just leave these parts. Yeah, okay. Expected. Then I also need my JSON viewer. Okay, so what we've done is we've split this up into lengths of 64 characters long, again, which means 32 bytes, EVM 32 bytes, and we have sort of 6 elements in this array. So let's take a look at the event log, which is this one here. So the first thing is index topic 1 is a bytes 32. Again, bytes 32. There's a 32 number there, which means fixed length. Use it as it is. Second one, there is no index topic, which means this is the first element in data, and it is a name of type bytes, which means it's a dynamic data type, and dynamic data type means there will be an offset. So the first line we see is the offset for bytes. Okay, so convert this hex to int. So hex to int is 1 to 8, so it's 1 to 8 bytes. Right, 1 to 8 bytes means how many lines of 32 bytes? Well, 1 to 8 divided by 32 is 4, right? So we skip 4, so 1, 2, 3, 4, we skip it, we start on the next line, and what is this next line? We go back to our rule. Our rule says after the offset, the next thing will be the length of the bytes. So the length of the bytes, again, hexadecimal format, convert this from hex to int, we get 14. What is 14? 14 is the number of bytes. To get the length, we need to times 2. So 14 times 2 is 28, which would mean the next 28 characters is the name. So we can sort of just count together, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Oh shit, did I miscount? I'm gonna assume it stops at 8, hopefully. And yeah, the next 32, oh, where am I? Yeah, the next 28 characters long is the string. So I'm gonna paste it here and just do a recount. So 2, 4, 6, 8, 10, 2, 4, 6, 8, 20, 2, 4, 6, 8, 10. So 8, 10. Okay, there you go. So this is the full, or this is the exact string that needs to be converted from hex to string. Why? Because oh no, I'm wrong. I don't have to convert this to hex to string. This is the bytes by itself, right? Yeah. I don't know why they don't use string here, because it is a type name. So this is where sort of context comes into play. You can sort of use your own judgment as to when you want to convert bytes to string. But fun fact, string is actually a subset of bytes, and that's why some strings can be converted to or make sense when you convert them from hex to int, but some bytes, or not all bytes, make sense when you convert them from hex to string, right? So they are the same essentially under the hood. So yeah, so I do see here that it's only 0, 0, and I have an extra pair. So let's just see how it goes. I'm gonna comment this out and just do something like hex decode string and see what we get. Boss with ETH. There you go. Not sure if this thing matters. I think it's just some space. Yeah, so decoding this gives us boss with ETH. No idea what that means. Maybe some metadata for their ENS, right? Yeah, ENS name wrapper maybe, right? But yeah, that's how you would treat bytes and also string. Right? So you apply this rule where it's an offset, and then there is a number of bytes, and then only finally the next line is the actual string that you need to extract and convert from hex to string if that applies. Okay, now that is different from arrays. Arrays, or I should say dynamic arrays, right? And the reason why it's different is because unlike bytes where you would use that string, arrays, there are multiple elements, right? There is a variable number of elements in this array, and so the rule is a bit different. The rule would be there is still an offset, right? But instead of the length, it would be the number of elements in the array, and then this would be the actual thing in the array, right? So it could be like element 1, element 2, and so on and so forth. So that's how dynamic arrays work, right? There is an offset, and after the offset, which it tells us where we should start looking, the first thing that comes up is the number of elements in the array. So this could be 2, 1, 5, whatever. And then immediately after the number of elements is the actual element in the array itself, or the actual object in the array. Now the caveat here, and this might be more advanced, is that if this element is a dynamic element, then you would apply then it would tell you the offset of where element 1 is. So this rule, you can substitute this whole thing into here. Okay, I don't think you encounter this often, but if you do, good luck. But yeah, you would sort of substitute this thing inside here, and then each element 1 would be the offset of where element 1 is, and then you also just follow the trail. But as long as you follow the rules itself, you should be fine. So let's see what a dynamic array looks like in person, right? So this looks rare, event is perfect, and if you click on the ABI, it's decoded for us, so we can just inspect closely. So we have So all these are static arrays, static data types because there is no brackets. And then address 2 is a static data type, right? Feed recipients, which means there's only 2 addresses. They cannot be more than 2, it cannot be less than 2. And then fee amounts will always be 3, so 1, 2, 3, right? But where it changes is item IDs and amounts. So item IDs is a variable length, and amounts is a variable length as well, which means it could be many, I don't know how many, right? A lot. And so how these show up in the data itself is there's an offset, it tells you the number of elements in the array, and then it tells you, and then is the actual first element of the array itself. So let's go to the raw data, and we can actually reverse engineer this. So 1751, convert 1751 from integer to hex. So into hex. We should be looking at a hexadecimal line, or a line that ends with 6D7. So let's find for 6D7 in our data. 6D7, there you go, 6D7, right? So this line, when converted from hex to int, is the token ID. So this is the actual element 1, and then before actual element 1 is the number of elements in the array, which will be this 1. So convert this from hex to int, you get 1. So it's telling me it's telling us item ID that there is 1 element in the item ID array, and the element is, or the first element is this one. Because you convert this from hex to int, you get 1751. Same thing for amount. It is not as clear because the amount, the value is 1. But these two lines over here, the first one would represent the number of elements in this amounts array, and then this one would be the value 1. So yeah, so that's how it is for dynamic arrays. You need to apply the rules. The rules look kind of similar, and the rules for bytes and string can be inserted into this over here. I also have a note here, like a special shout out for tuples and struct. Essentially the same thing, but tuples and struct means in Solidity you can sort of create your own data type, a collection of data types. A common example is a person, like a struct person, and you can say something like, uint for the age, or like string for the name, right, so on and so forth. And so all this collection is a custom data type, and those are called, and this is a struct, right? Tuples are just structs without this age and names. Yeah, you won't encounter this too often, but Cport data uses tuples. Fun fact. But okay, so that's the common Solidity data types that you will encounter pretty frequently. And yeah, this is exactly how you would sort of handle these situations. I think uint, address, booleans, these are the 3 most common ones. As long as you know how to handle this, you should be fine. And yeah, I think that's it for the video. If you have any questions, leave them down below. And thank you for watching. I'll see y'all in the next one. Bye.